This video tutorial is going to go over how to calculate formula mass, which is the official name for the molar mass of a compound. Earlier this week, we talked about molar mass of elements, and you found out by doing sort of a proof that the atomic mass for an element, as it says on the periodic table, if we have 1 mole of that element, that atomic mass is the molar mass. We just change the units from AMU to grams per mole. So for example, here for manganese, its molar mass would be 54.938 grams per mole. We just use the number off the table. Now, if we have something that has a chemical formula, we can do the molar mass by just adding up all the components. For more simple equations like HCl, then we would look up the molar mass of H and look up the molar mass of Cl and figure out how many atoms of each element are in this formula. There aren't any subscripts, so it's implied that there's 1 hydrogen and 1 chlorine. When we look on the table, hydrogen is 1.008, so I'm going to do this times 1.008. We look on the table for chlorine, and it is 35.453. 35.453. Now, since these are just times 1, that makes it very simple. It's 1.008 and 35.453. To get the mass of that whole formula, we take these components of each element and just add them together. 1.008 plus 35.453 equals 35.461. And when we report a formula mass, we put it as grams over 1 mole. And then I will frequently ask you to show me the alternative version, which would put 1 mole in the numerator and 35.461 grams in the denominator. That's for a fairly simple formula that had no subscripts. But what if we had something a little bit more complex, like H2O2? We still just have 2 elements for this one, H and O, but this time there are subscripts that tell us there's 2 hydrogens and 2 oxygens. We had looked up hydrogen up here, and it was 1.008. Now we need to look up oxygen. It is 15.999, which a lot of people just round off to 16. So we will do that here. So we need to multiply 1.008 times 2 because of the 2 hydrogens, and we get 2.016. And then we need to do 2 times 16, that's 32. And then we need to add those 2 together, and that's going to be 34.016. And we report that as grams over 1 mole. And then the alternate would put 1 mole in the numerator and 34.016 grams in the denominator. They can get even more complicated than this. Sometimes when you have a formula with a polyatomic ion in it, there are parentheses. So for example, if we had calcium nitrate, the formula would look like this, where we have parentheses and a number outside of it. It's a lot like algebra, where this number outside distributes to everything inside the parentheses. So we have 3 elements this time: calcium, nitrogen, and oxygen. Calcium is not in the parentheses, and there's no number next to it, so we just have 1 calcium. Nitrogen is in the parentheses, and there's a 2 outside, so we have 2 nitrogens. And then oxygen is also in the parentheses. It has a 3, so we need to multiply the 3 and the 2 to get 6 oxygens. Then we have to look up the molar masses on the periodic table for each of these elements. Calcium is 40.08. Nitrogen is 14.007. And we had said earlier that we can just call oxygen 16 because it's so close. So we have 1 times 40.08. We have 2 times 14.007, so that's 28.014. And we have 6 times 16, which is 96. And I just need to add all of those together. So 96 plus 28.014 plus 40.08, and I get 164.094. And don't forget to report it with units, grams over 1 mole, or 1 mole over 164.094 grams.